Why is there something rather than nothing? That's the question. Not how the universe works. Physicists are very comfortable with that one. Not what it's made of, not how old it is, not what happened in the first fraction of a second after the Big Bang. Those are hard questions, but they're the kind of hard that science knows how to handle. This one is different. This one sits right at the edge of what asking a question even means. Most physicists won't go near it. They'll talk about the Big Bang, about quantum fields, about the first microseconds of existence. And then, if you push them on why any of that exists at all, they'll either hand it to religion or change the subject. And I understand why. It's not cowardice. It's that the question seems to live just outside the boundary of what science can reach. I never thought that was a good reason to stop asking. I didn't have a clean answer. I want to be honest about that from the start. But I had something I think is more valuable than a clean answer. A way of sitting with the question that doesn't flinch, doesn't reach for comfortable nonsense, and doesn't pretend the difficulty away. And when you really sit with it, when you follow the terms of the question all the way down, you find that it's stranger and more interesting than you thought. Start with nothing. When most people ask why there's something rather than nothing, they picture nothing as a kind of dark, empty room, a quiet void, no matter, no light, just emptiness stretching in all directions. That's not nothing. That's space. And space is something. Space has geometry. It can be flat or curved. It expands. It contracts. Gravity is literally the curvature of space. Space has quantum fields threaded through every part of it. Space obeys mathematical laws. The moment you picture an empty room, you've already smuggled in an enormous amount of structure. 3 dimensions, spatial relationships, the possibility of something being somewhere rather than somewhere else. True nothing is almost impossible to think about. No space, no time, no fields, no forces, no mathematical laws, no logic, no possibility. The problem is that every tool you'd use to think about nothing, your mind, language, logic, mathematics, is itself something. You can't step outside of existence to examine non-existence from a neutral vantage point. The question is asking you to think about a state in which thinking wouldn't be possible. Every time you try to define nothing carefully, it dissolves into paradox. The question gets harder the more precisely you define the terms, which is the opposite of how most questions work. Here's where I want to push deeper because there's a version of this question that's even harder than the one people usually ask. People ask, why is there matter? Why is there energy? Why did the Big Bang happen? And those are real questions. But even if you answer all of them, even if you produce a complete physical account of the first instant of the universe, a perfect description of how matter and energy emerged from a quantum fluctuation or whatever it was, you still haven't answered the deeper question. You haven't explained why the laws of physics that produced all of that exist. Why those laws? Why does mathematics describe physical reality at all? Why is the universe the kind of place where electrons have the charge they have, where the speed of light is what it is, where the constants of nature sit at the precise values needed to produce atoms, chemistry, stars, planets, life? The universe didn't just need a starting condition. It needed an operating system, a set of rules. And those rules are, in some sense, even harder to explain than the matter they govern, because at least matter is something you can point at. Where did the laws come from? Now, let me tell you something that modern physics discovered, which changes the shape of this problem considerably. The vacuum, empty space, is not empty. This is not a philosophical statement. This is experimental fact. When you remove everything you can remove from a region of space, evacuate it, cool it, strip out every particle, what remains is not nothing. What remains is the quantum vacuum, and the quantum vacuum is alive with activity. Virtual particles constantly appear and disappear, popping into existence for tiny fractions of a second, borrowing energy from quantum uncertainty and paying it back before anyone can catch them. The vacuum has energy. This is called vacuum energy or zero-point energy, and it's measurable. It has observable effects. The Casimir effect, for instance, a tiny but real force between two uncharged metal plates placed very close together in vacuum, exists because of the quantum vacuum's energy. The vacuum fluctuates. It is never truly still. It cannot be truly still because quantum mechanics forbids a state of perfect emptiness at perfect rest. And this matters enormously for the question of why anything exists, because it suggests that nothing, true, perfect, total nothing, may be physically unstable. That given the laws of quantum mechanics, something is in some sense more natural than nothing. A perfect vacuum, if such a thing could exist, would be prone to fluctuating into something, which raises the obvious question of where the laws of quantum mechanics that make nothing unstable came from. But it's still a profound shift. The universe's existence might not require a special explanation. Non-existence might be the thing that requires explaining. There's another asymmetry buried in the early universe that I want to show you, because it's one of the strangest facts in all of physics. When the Big Bang happened, the energy of that event should have produced matter and antimatter in exactly equal amounts. Matter and antimatter are mirror images of each other. Same mass, opposite charge, and when they meet, they annihilate completely. They convert entirely into energy, leaving nothing behind. If the Big Bang had produced perfectly equal amounts, which is what the symmetry of the laws of physics predicts, the entire universe would have annihilated itself in the first second. Every particle of matter would have found its antimatter partner. Everything would have become light, and then that light would have spread out through an empty, expanding void forever. No atoms, no stars, no planets, no you. Something broke the symmetry. We don't fully know what. For every billion antimatter particles, there were 1,000,000,001 matter particles, a tiny excess, an imbalance so small it's almost nothing, and yet it's everything. Because when the annihilation was over, that 1 in a billion excess survived. All the matter in the observable universe, every galaxy, every star, every planet, every atom in your body, is the leftover residue of that asymmetry. You are the crumbs, the debris from a near-perfect annihilation that happened 13 billion years ago. We don't know why the asymmetry exists. We have candidates, we have theories, but this is genuinely unsolved. The fact that anything exists, that you exist, depends on a broken symmetry whose origin we cannot fully explain. That's not a gap in the textbook that'll be filled in next year. That's an open wound in physics. Now I want to tell you why I never found the popular answers satisfying. When people push this question, why does anything exist? They tend to reach for three things: God, the multiverse, or the anthropic principle. And I was skeptical of all three, not because they're necessarily wrong, but because of what they do to the questioning. The God answer, whatever you think of its truth, functions as a conversation stopper. You've explained existence by appealing to a being whose own existence is equally unexplained. You've moved the question back one step without dissolving it. If the universe needs an explanation, so does whatever created it. You haven't solved the problem, you've renamed it. The multiverse does something similar. The idea that our universe is one of an enormous or infinite number of universes, each with different laws and constants, it's a genuine scientific hypothesis, not just speculation. But as an answer to why anything exists at all, it falls into the same trap. If there's a multiverse, where did that come from? What are the laws governing the process that generates universes? You've expanded the thing that needs explaining, not explained it. And the anthropic principle. This one is the most seductive and the most empty. The anthropic principle says the universe has the properties it has because if it didn't, we wouldn't be here to observe it. It's logically airtight. It's also, I'd argue, nearly useless as an explanation. Of course, we observe a universe compatible with our existence. We couldn't observe anything else. But that tells you nothing about why a universe compatible with our existence exists in the first place. It tells you why we see what we see. It doesn't touch why there's something to see. It answers the wrong question confidently, completely. and people mistake the confidence for depth. Now, let me tell you something about symmetry breaking, because it's the physics concept that I think gets closest to the real structure of this problem. The universe we have is not the only universe that could have existed given the initial conditions. In the very early universe, fractions of a second after the Big Bang, at temperatures and densities we can barely calculate, the four fundamental forces were probably unified: gravity, electromagnetism, the strong nuclear force, the weak nuclear force, one symmetry, a system with multiple possible outcomes. As the universe cooled, that symmetry broke, the forces separated, and the specific way they broke, the specific values the constants settled into, produced the universe we have. But it could have broken differently. The constants could have settled into different values. A universe where the strong nuclear force is slightly weaker produces no stable atoms. A universe where gravity is slightly stronger collapses before stars can form. A universe where the cosmological constant is slightly larger expands so fast that matter never clumps together. The vast majority of possible universes, possible combinations of constants and laws, produce nothing interesting, no structure, no chemistry, no complexity. We happen to be in one of the ones that worked, and we don't know if that's a miracle, a selection effect, a consequence of a multiverse, or something we don't have concepts for yet. Here's what I think is the most honest thing that can be said about this question. I don't know, and I mean that in the most precise scientific sense, not as a shrug, not as a placeholder for future discovery, but as a genuine statement of the current epistemic situation. This is a question where the honest answer is that we are at the edge of what our tools can reach. Pretending otherwise, dressing up one of the comfortable answers and presenting it as settled, is a kind of lie. And I never had much patience for that kind of lie, even when it was dressed in very sophisticated mathematics. But not knowing is not the same as the question being meaningless. That's the thing I want to be clear about. The question, why does anything exist, is not a confused question or a badly formed one. At least it's pointing at something real. It's the most fundamental question you can ask about reality. And the fact that it resists easy answers is a feature, not a bug. It means we're asking something genuinely hard, not something we failed to look up. And here's the thing that I keep coming back to, the thing I find genuinely remarkable. The universe, whatever it is, however it came to be, arranged itself over 13 billion years into configurations complex enough to ask why it exists. Matter became atoms. Atoms became molecules. Molecules became chemistry. Chemistry became life. Life became nervous systems. Nervous systems became minds. And minds became capable of looking out at the cosmos and finding it puzzling. The universe produced out of its own substance the capacity to wonder about itself. That's not an answer to why anything exists, but it's not nothing either. The question itself, your ability to ask it, to feel the weight of it, to be genuinely unsettled by the possibility that there might be no answer. That's part of the story of what the universe is, what it does, what it's capable of producing. The universe may not have a reason in the way humans use that word. Reasons require minds, and minds came billions of years after the universe started. But it has a structure, it has laws, it has a specific, finely tuned set of properties drawn from a vast space of possible properties, most of which lead nowhere. That specificity, that particularity, is what makes the question so stubborn. If the universe were just any old configuration of matter and energy, the question wouldn't bite so hard. But it's this one, these laws, these constants, this specific outcome out of all the possible ones. Stay curious, stay honest. Don't fill the silence with comfortable noise. That was my answer, not a theory, a posture, a way of standing in front of the question without flinching and without pretending. The question, why does anything exist, is not the end of physics. It's where physics begins. Every equation we've ever written, every experiment we've ever run, every constant we've ever measured, all of it is an attempt to understand a universe whose existence we cannot yet explain. We're inside the thing we're trying to understand. working from the inside with tools made of the same stuff as the mystery. That's the situation. And I find that genuinely, without performance, one of the most extraordinary things I can imagine.